Hello and welcome again. In this video, we're going to finish up our discussion on DMA 20, Section 1, an Introduction to Fractions. In our last video, we covered fraction definitions, graphing fractions on a number line, and then we explored some special fraction forms. In this video, we'll cover equivalent fractions, prime factors of whole numbers, and then simplifying fractions. Let's start with a definition for equivalent fractions. Two fractions are equivalent if they represent the same number. That is, equivalent fractions represent the same portion of a whole. So let's look at this example. Our first fraction is 2/4. So since the denominator is 4, I've broken the circle into 4 equal parts. Since the numerator is 2, that means we have 2 of these parts, so I'll go ahead and shade 2 of these parts. So that represents the fraction 2/4. Now in our second fraction, 1/2, our denominator is 2, so I've broken this into 2 parts. We have 1 of these 2 parts, so we'll just shade 1 of these regions. And as you can see visually, these two fractions are equivalent. Both 2/4 and 1/2 represent 1/2 of this fraction. Next, we'll find out how to build equivalent fractions. To build an equivalent fraction, we must multiply the numerator and the denominator by the same number. This is also known as multiplying by a factor of 1, and we'll see why it's called that in just a moment. So in our example, we want to write 3/5 as an equivalent fraction with a denominator of 35. So we'll start with our original fraction, 3/5. And now we have to multiply the top and the bottom by the same number to give us an equivalent fraction with a denominator of 35. So 5 times what will give us 35? If we remember our times tables, we'll know that 5 times 7 will give us 35. So since we're multiplying the bottom by 7, to keep this equivalent, we have to do the same thing to the top. So we'll multiply the top by 7 too, and 3 times 7 will give us 21. So the equivalent fraction with a denominator of 35 is 21/35. Now, remember, I told you that I was going to show you why this was known as multiplying by a factor of 1. Well, think of this as the fraction 7/7. 7/7 is what? 7 divided by 7 is 1. So we kind of think of this as our factor of 1. We're really just multiplying by 1, and that shows why these are equivalent. When we multiply something by 1, we don't change that number. We just get it back. So when we multiply by a different form of 1, we haven't changed the number at all because we're multiplying by 1. We're just expressing it in a new way. Before we continue on, we have to talk about the definitions of prime and composite numbers. A prime number is a whole number greater than 1 that has only itself and 1 as factors. So that's important. Only 1 and itself go into it, and it has to be bigger than 1. 1 isn't prime. I've listed the first 10 prime numbers here. There's 2, only divisible by 2 and 1. 3, only divisible by 3 and 1. And the same follows for 5, 7, 11, 13, 17, 19, 23, and 29. All of these numbers are only evenly divisible by themselves in the number 1. However, a composite number is a whole number greater than 1 that is not prime. That is, there's another number that will go into it evenly other than itself and 1. And here's the list of the first 10 composite numbers. 4 is composite because it's also divisible by 2. 6 is composite because it's divisible by 2 and 3. 8 is composite because it's divisible by 2 and 4. 9 is divisible by 3. 10 is divisible by 2 and 5, and so on. All these numbers have numbers smaller than it that will go into it evenly. And for these composite numbers, we can factor them into the product of two or more prime numbers. That is, we could express them as a product of primes. And this product is called the prime factorization. Let's do an example involving prime factorization. Here we're asked to find the prime factorization of 210. Just by looking at this number, we can probably tell that it's not prime. It ends in 0, so we know 10 is going to go into it. It's and 5. It's even, so 2 is going to go into it. So there's a lot of different numbers that we might be able to factor out of 210. To make sure that we get every prime possible out of 210 and write the complete prime factorization, we're going to use what's called a factor tree. So we start by writing the number that we're going to factor, and then we write two branches coming off that number. And on the ends of those branches, we're going to write our leaves, or the numbers that will go into it evenly. So I said that 10 would go into 210. So that's the first number that I'll write. And 10 times what gives us 210? 21. So at these leaves are the two numbers that will multiply to give the number above it. Now neither of these two numbers, 10 or 21, are prime. So we're going to continue to factor these numbers. Draw two branches off each of those. 10 we can say is 2 times 5. 2 times 5. And when I get to a prime number, I like to circle it so I don't forget about it later. 2 is prime, only divisible by 2 and 1. And 5 is prime, it's only divisible by 5 and 1. So I've got two primes there, and since those are prime, I'm going to stop. I don't need to factor them any further. Over again to 21, this is a composite number. We can say this is 3 times 7. 3 is prime, so I'll circle it. 7 is also prime, so I'll circle it. And now I'm done. I've got this down to the product of all primes. So when I write the prime factorization of 210, I just write it as a product of all these circled numbers. Now I only write the circled numbers. I don't have to write the composite numbers that we found in the middle, like 10 or 21, just the primes. So I like to write these in numerical order going up. So we'll say this is 2 times 3 times 5 times 7. And if we investigate this a little further, we can see why that's true. 2 times 3 is 6, and then we do 6 times 5 and we get 30. Then we do 30 times 7, we get 210. Next, we're going to explore how to simplify fractions into the simplest form. A fraction is in simplest form, or also known as lowest terms, when the numerator and the denominator have no other common factors other than 1. That is, there's no number that will go into both of those evenly other than 1. So we have some examples here. We want to simplify these fractions into simplest forms. Now, just like when we were building equivalent fractions, when we were multiplying the top and the bottom by the same number, to simplify a fraction, we'll have to divide the top and the bottom by the same number in order to reduce it. Okay, so this first fraction, 10 over 25, I notice that 5 will go into both of these numbers evenly. So I'll divide the top by 5 and the bottom by 5. And that'll give me an equivalent fraction. 10 divided by 5 is 2, and 25 divided by 5 is 5. And now this fraction is in simplest form, because no number will go into both 2 and 5 evenly. In our second example, we have 3/9. Both of these are divisible by 3, so I'll divide 3 by 3, and I'll divide 9 by 3. To get an equivalent fraction. 3 divided by 3 is 1, and 9 divided by 3 is 3. So our fraction in simplest form here is 1/3. Next, I have 90 over 105. There's a lot of different numbers that can go into both of these, so we're going to do this in multiple steps. First, I noticed that they both end in 0 and 5, so I'll divide them both by 5. "90 divided by 5 is 18. We might have to do some long division to figure this out. And then 105 divided by 5 is 21. Okay, so now we do have an equivalent fraction, but it's not in simplest form yet, because we can divide another number into both 18 and 21 evenly. I noticed that they're both divisible by 3. So I'll divide 18 by 3 and 21 by 3 to get a second equivalent fraction. 18 divided by 3 is 6, and 21 divided by 3 is 7. And now we have this fraction in simplest form, because there's no number that will go into both 6 and 7 evenly. So sometimes you'll have to divide by multiple numbers until we get the number into lowest terms. Before we end this video, I wanted to give you some hints to help you find what numbers might go into some of our fractions evenly. And so I've given you this list of some divisibility rules. Now, these are in your Blackboard courses under course documents, I believe, or you could ask your instructor if you're in a seated class for a printout of the full list of these rules, but I'll just show you the ones that I use the most. The first is to check if a number is divisible by 2. So all even numbers are going to be divisible by 2. That is, numbers that end in 0, 2, 4, 6, or 8. Any number ending in those is going to be divisible by 2. So if you know that the top and the bottom of your fraction are both even, then we know we can divide them both by 2. Next is dividing by 3. So we're going to add up all the digits of the number. If that sum is divisible by 3, then the whole number is divisible by 3. So we have this example, 12,123. We add all of those digits up. 1 plus 2 is 3, plus 1 is 4, plus 2 is 6, plus 3 is 9. I've written that out there. 9, that sum, is divisible by 3. So that means that I can divide this whole number by 3. That's a really helpful tip for large numbers. Next we have 5. So you heard me mention this earlier. Any number that ends in 5 or 0 is divisible by 5. And then 9 follows the same rule as 3. If we add all the digits up, and that sum is divisible by 9 this time, then the whole number is divisible by 9. So in this example, 43,785, we add all those digits together one by one. 4 plus 3 is 7, plus 7 is 14, plus 8 is 22, plus 5 is 27. And 27 is divisible by 9, so that means this whole number is divisible by 9. Again, very helpful for large numbers. And the last tip that I use frequently is dividing by 10. If a number ends in 0, then it's divisible by 10. So we know very quickly if the top and bottom numbers of our fraction both end in 0, then we can divide both of those numbers by 10 to start simplifying that fraction. Again, this is not a comprehensive list of all the rules that are posted in Blackboard, but I think that these are the 5 that are the most helpful. So to review, in the second part of our Section 1 video, we covered equivalent fractions, prime factors, composite numbers, and prime factorization, and then simplifying fractions as well as some divisibility rules. In our next video, we'll start Section 2, which is multiplying fractions. See you next time.